What did somebody get for the length of PQ? How did you get that? Uh-huh. Interesting. Well, your logic is correct, but I think the algebra you did was a tad wrong. But the logic was flawless, and I guess you got that by just doubling this number. Is that what you did?
Yeah, I got down to the decimal and to the unit form. I did the fraction 7/8 and got to the decimal to the unit form.
So you got like 1.825 and added it, or 875, excuse me. Yesterday, when we were talking about congruent, one thing that we didn't talk about a lot is that if you ever see, these are called tick marks or dashes. If two pieces have the same number of dashes or tick marks, then that implies they're congruent. So these could have, and the reason that's helpful is you'll see stuff later with like all kinds of lines everywhere. But this one up here might have 2 tick marks, and this one might have 2 tick marks. So these two would be the same. And this one might have 3 tick marks, and this one would have 3. And those would be the same. So wherever you see the same number of dashes, you have congruent pieces. So you guys are both correct in your logic. You should have hopefully concluded this was also 1 7/8, and then added those two together. So basically multiply it by 2, which I will do on my calculator. Now you could have converted it to a decimal. I don't really care unless it specifies, but I doubt it ever will. I'm actually more of a fraction person, but if you did convert it to decimals, here's how you could have done that. So just like you said, then just put the 1 back on and multiply that by 2, 3 3/4. And if you want that as a fraction on these calculators, if you hit math, enter, enter, it'll convert it back to a fraction for you, 15/4. Or I believe this is 3 3/4. Now the easiest way to actually add the fractions, if you had chosen to leave it as a fraction, the easiest way to do that would be to make this a mixed fraction. A compound fraction, improper fraction. 8 times 1 is 8 plus 7, so this would be 15/8, and then you add that to itself, which would give you 38, which reduces to 15/4, which is the same thing as this, if you had chosen to do it like that. Okay. Are there any questions on the DOM? Click. 1.3, midpoints and distance formulas. 1.3. Andrew, was it you that said you had forgotten the part of your DOM the other day? When you turned it in? Oh, I think it was. But you didn't get it in? I was going to remind you. Okay, great. Okay, 1.3, midpoint distance formulas. Pieces of notes for the day. And I'm going to just start tacking on the Spanish down below. You obviously do not need to record those, but I thought they might be helpful down there. So get those notes down if you're a note taker. And we'll talk about them. Midpoint. The midpoint of a segment is just what it sounds like. It is the point in the middle. So a midpoint will always cut a segment into two pieces, two equal pieces. That's the important thing there. Midpoint in the middle. Now, if something goes through the midpoint, then you could also call it the bisector of that particular segment. A bisector is just like a midpoint, except, it doesn't have to be just a point. It could be a line, it could be a ray, it could be another segment. Anything that slices something directly in half bisects it, and therefore it's bisector. So the word bisect means cut in half. That will be a very important word for you to know on the test, because the word bisect or bisector comes up a lot. And if you know what it means, you know just to divide by 2 most of the time. And if you don't, then you'll be a little confused. So bisect is something that cuts it directly in half. Midpoint and bisect are pretty much the same thing, except the midpoint is a point and a bisector is anything but a point. Questions about anything you see on the board? Okay. In the skateboard design, VW bisects XY at point P. And XT, which is from here to here, is 39.9 centimeters. How long is XY? How long is the whole piece? And how would I find that? Somebody raise your hand and tell me how I'd find that. Yes, sir. Yeah, exactly. When things have been bisected, it is normally just as simple as either multiplying by 2, or if they had said the whole thing was that, you would divide by 2. But in this case, they gave you part of it, and they said it's bisected, so you're going to double that, and what would that give you? Close. 79.8, that's right. 79.8 centimeters. So you said 39.9 times 2, and you get your answer. 39.9 times 2, 79.8. Questions? That's a bisecting problem. Point M is the midpoint of VW. Find the length of VM. Now this is exactly what we did yesterday as far as, remember those last problems where we had to take entire equations and do things with them? Same thing. M is the midpoint of VW. So what do we know about VM and MW? They're excellent word choice. I'm so glad you didn't say equal. They are congruent. Very good. And if they're congruent, then that means their measures are, yeah, they're equal to each other. So what do you think I'm going to do with those little 2 blue pieces? Well, what did you just say? You said those pieces were what with each other? You said they are congruent, which therefore means that they equal each other, so that's what you do with them. You set them equal. If they equal, you set them equal. 4x minus 1 equals 3x plus 3. Subtract 3x. You get x minus 1 equals 3. Add the 3. Add the 1. Now, it actually asked us for the length of VM. That's what it asked us for. So we plug it back in. So this would be 4 times 4 minus 1. Okay. Questions about any step we took right there? Yes, sir.
We have 3x and 4x, so 3x is 4 more.
Because the minus 1 and the plus 3? That's a good observation. That's a great observation. That's actually true if these only differ by 1x. Because that means when you subtract it, you're just going to get x equals, and all it's going to come down to is those two numbers. So you were right. Now, if these had differed, but this was like 4x and 2x, then it would have been the difference in those numbers divided by 2. So yeah, you're absolutely right in making that connection. The only problem with just thinking about like that universally is, sometimes it might get a little more complicated, like 5x plus 2, 1x minus 7. Now all of a sudden you have to keep track of all these numbers in your head. So that's why it's smartest just to set it equal, but that's a very true observation. All right, in exercises 1 and 2, identify the segment bisector. So just say what it is that's bisecting the segment, and then find the length of PQ. You need to be doing these on your own. I'll come around and help. Identify what it is that's bisecting the segment, and I'll help you with the first one. Now, you don't have to do number 1. We did it in the DOM. Okay? We already know that the length of PQ is 3 3/4. We did it earlier. But the other thing you need to be saying is, what's bisecting PQ? That would be ray MN. Ray MN is bisecting PQ. So I've labeled that. So here, tell me what's bisecting PQ, and then solve for the length of the whole segment. And I will come around and assist. This is just 2 of you here, Elijah. Are you going to sit there permanently? You want to sit in that seat, that way it's clear this up a little bit. Thank you. Who can tell me what is what is bisecting number 2? Yes, sir. I would accept that. It's actually, if you were going to consider it, I know. Actually, it's this one. Thank you so much. Hey, you too, and I really appreciate it. Yeah, oh, that's another thing I want to mention to somebody. This fell off. Not that it matters to me, but it makes a loud clang. Yeah, the stop came off. All right. Okay. If you were going to consider it by one letter, it would actually be line L. Just because, here's the problem with calling it line M. That could be this line or this line, since M is actually the point of intersection. Now, I would have expected line LM, although L is technically not a point, or line L, something like that. Oh, okay. Well, then I bet, okay. If you didn't see the L, then technically you would have to be given another coordinate to name the line, because I think that was the point of intersection. But regardless, I knew you knew what we were talking about. We're going to move on. Yes, sir. We are. But it had 2 questions. It said, first identify the bisector, then find PQ. So, we identified the bisector. How do we find PQ? One of these. You two have been awesome, but you're carrying the load. We need people to step up. What if you guys got in foul trouble? We wouldn't have any scoring. I need somebody to step up with an answer to how to find the length of PQ. Can't rely on Michael and Scotty all the time. That's a basketball reference. I know those aren't your names. Yes, sir. You're exactly right. Because they were bisected, you can set them equal. Very good. So you said add the 2x, which gives you 7x minus 7 equals 11. I'm going to get rid of this. Then you add the 7. Divide both sides by 7. I bet they left it as a fraction. 11 and 5/7. That's not what I got at all. Oh, that's just x. That's right. That's right. Didn't read the instructions. What was I saying the other day? That's what's going to get you on a test, and look, it got me. So we were right. Yes, you need to plug that in for x. Then that'll hopefully get us 11 and 5/7. So the 5 times you plug 18/7 in for the two x's. So that'll be 90 over 7 minus 7. Now, in order to make this one nice fraction, how can we convert 7 to something over 7? 7 equals what over 7? Well, what's the natural denominator on 7? If I were to make 7 into a fraction, wouldn't it just be over 1? What did I do to the 1 to get to a 7? What did I multiply by? So what do I do to the top? So this is the same as 49/7. That way your fractions is just easier to work with. Same thing here. If we multiply this by 7, that's the same as 77 over 7 minus, was that 36 over 7? Now we have all common denominators. So 90 minus 49 is 41 over 7 equals, well, I already, wait. What am I doing? I already know they equal. This was stupid. Instead of setting them equal, I already know they equal. What should I have done to find the whole length? Added them. I should have added them. So plus 41 over 7, which gets me 82 over 7, which does reduce to 11 and 5/7. You could have left it as 82 over 7. You could have given it to me as a decimal, which would have been like 11.7 something. What was it? 11.8. Or you could have reduced. This would have been probably the most impressive way to answer it, but I would have accepted either of the other two as well. You just need to know, on your test, I like to give multiple choice tests. On your test, the answer would probably be like this. So if you got this or 11.8 or whatever it was, then you would just need to know how to know if that was the same as that. Plug them both into the calculator, see if they give you the same decimal. But questions on any step we took to get this? Yes, sir. 6. So you got this. Oh. Here's the problem with putting things in decimal form. That's not necessarily wrong, but 18/7 is not a rational number, which means you would have to round it off somewhere. And when you round off a number and then plug it back in, here's essentially what you did. You took the amount that you rounded off. What did you round this to? 2.8? 2.6? So let's say you rounded off just 0.1, okay? But now you're multiplying that 0.1 that you rounded off by 5. So now you're off by 0.5. And then you multiplied it by 2. So now you're off by 0.5 and 0.2. So now you're off by 0.7. And the problem with rounding is when you plug it back in, every time you rounded it, it compounds it. So that's why you don't want to do that. Now what you could do, if you don't like If you don't like manually working with that fraction, you could have punched this whole thing in the calculator as is. And I'll show you how to do that right now if you want. Here's how you could have done it without having to do any of the fraction work yourself. Once you found that this was 18/7, you could have done this step straight in the calculator. 5 times 18/7 minus 7 plus 11 minus 2 times 18/7. Enter. There it is in decimal form. Math, enter, enter. That's what we got in fraction form. 82/7. But yeah, I bet anything that the reason is just because the rounding compounded on you. Other questions? That was a good point. Thank you for bringing that up. Other questions? All right. The midpoint formula. I'm going to be giving you two coordinates and asking you to find what point lays in the middle of those on the coordinate plane, for which you're going to need this formula. Now, hopefully you're not putting anything today in your postulates and theorems section. Nothing today goes in that section. These are just general notes. You're definitely going to need this formula in your notes. That is the formula to find point M. If we give you A and B, that's the formula to find point M. I'm actually going to be giving you two formulas today. That's one of them. And I guarantee you, you may not have thought of it like this, but you've all used this formula before. Every one of you. You just didn't think about it at the time. For instance, if I said, what's in the middle of 3 and 7? What number is in the middle of 3 and 7? 5. How'd you get that? 5 is 2 from 3 and 2 from 7, right? You took the average. You took 3 plus 7, divided it by 2. If I said I'm going to give you $20 this birthday and $40 next birthday, and then after that I'm going to give you the number right in the middle, how much money would that be? $30. You just took the midpoint of those two numbers. You added them up, divided by 2. That's all this is. I'm going to give you two coordinates, and you're just going to find their average. So let's look at the x values. What are my x values? 1 and 4. So you add those up. 5 divided by 2. And your x midpoint is 5/2. We took our x values, put them right here. Then we took our y values, put them right here. Now the thing to remember about this is it's a coordinate you're getting. You're going to have two separate numbers. You're going to have an x and a y. People think formula. They think, what's the answer? What's the one solution? But when you're looking for a coordinate, there's not just one solution. You're looking for an x and a y. So 4 plus 1 over 2 is 5/2. Negative 3 plus 2 over 2 is negative 1/2. And that is your midpoint. And if I ask you to graph that, which I will today, here's how you graph it. Here's R, here's S, and there's your midpoint, right in the middle. questions. Let's look at this in a slightly different way. What if I said 6 is in the middle of 5 and what number? How'd you get that? Oh, yeah, you do. But it was so instinctual to you, what? 6 is in the middle of 5 and what number? And he said 7. And he's right. And how'd you know that? Because you said, well, 6 is only 1 from 5, so what's 1 on the other side of 5? 7. Or if I said 4 is in the middle, 4 is in the middle of 1 and what number? You'd say, well, 4 is 3 from 1, so what's 3 from the other side of 1? I mean, on the other side of 4? 7. Yeah.
How would you know which one is that one and why?
Good question. Good question. It doesn't. Well, here's the thing. Because you're adding is a commutative process, it doesn't matter. 1 plus 4 and 4 plus 1. The only thing that matters is that you're consistent. Okay? If you're going to do 1 plus 4, so if you're going to use this x first, then you want to use this y first. Okay? Now, even if you mix that up, it actually shouldn't make a difference for this formula, but we're going to be doing lots more formulas where that will matter. So it's a good habit to just get into using consistent order, but it doesn't matter which one's which. Good question. Now, let's look at one like we were just talking about. This time, I'm going to give you the midpoint and one of the endpoints, and you have to find the other endpoint. Now, it's just like we were just talking about. 2 is in the middle of 1 and what number? 3. 2 is in the middle of 1 and 3. 1 is in the middle of 4 and what number? Well, that's a little harder because now you have to go to negative. So here's how you do it mathematically. You can still use the formula that I just gave you. The only difference is, on the last problem, what did I give you? I gave you these two numbers, and you had to find this, right? This time, I'm giving you this number and one of those, and you have to find the other one. That's the only difference, if you wanted to use the formula. You could still just flat out do these logically if you thought about them, but I'm giving you one of the endpoints, 1 and 4, and I'm giving you what they equal. I'm giving you the x coordinate is 2 and the y coordinate is 1, and you have to solve for x and y. So, we multiply by the 2, subtract the 1, got 3, multiply by the 2, subtract the 4, got negative 2, and there's your other midpoint. 3, negative 2. That would be point K down here. You can do it either way. You can do it using the formula, or you could do it using logic. By the way, every example we do is in your book. Your book actually has a lot of good resources. So if you're ever at home and like, I can't think, and whatever reason the video's not working or whatever, your book has all these examples in there. So you can always go back and look at them. I'm going to have you do one of these on your own in just a moment. So please raise your hand if you have a question about where any of these numbers came from. All right. Try those two problems. Try those two problems. Raise your hand if you have a question. I can help you. Bless you. Oh, it's actually the same formula. I tell you what, I'm going to answer that up there because I'm going to kind of rewrite this formula for you with that. Okay? Yes, sir. Okay, you did it one. Okay. You put both of the coordinates, this between 1 and 7, and then 1 and 7, and then 2 and 8, the x's and the y's. Now, to make this easier, I'm going to tweak that formula I gave you just a bit. The formula that I gave you was this. But instead of just putting it as a coordinate, I'm going to write this as, that is the x-coordinate of your midpoint. And then, now that may seem a little redundant to you, except that'll help you use the same formula for both problems. On number 3, what did they give you? They gave you both x1 and x2. So on number 3, they gave you, bless you, 1 and 7. And then they also gave you, what was this, 2 and 8? 2 and 8. And what did that give you? 8 over 2, which equaled 4. And what's 2 plus 8 over 2? 5. So you should have gotten the midpoints 4, 5. 1 plus 7 over 2. 2 plus 8 over 2. Are there questions on that one before we move to the other one? Okay, now, if you go back to that formula that I just changed a second ago, x1, x2, xm, y1, y2, ym. Now for the second one, what did they give us? They gave us the midpoints. That's where this would go into your formula. That would be negative 1 here, negative 2 here, and then they gave you one endpoint, which was one of these and one of these. Now you have to find this piece and this piece. That's how you would use the same formula for both. So multiplying by 2, that's 4 plus x2 equals negative 2. Subtract the 4, and x2 equals negative 6. Negative 6. The second one, multiply by the negative 2. Subtract the 4. And y2 is going to equal negative 4 minus 4, negative 8. Negative 6 and negative 8. So if you tweak your formula to be the first one equals xm and the second one equals ym, it may be a little bit more helpful to you later when you are solving these. Questions? Trip, did that answer your question? Excellent. Other questions? Would you like me to leave this on the board for a moment? Last formula. We're almost done. Last formula is the distance formula. You essentially need this in your notes. And make sure you label it the distance formula. You will need this all year. And then you'll need it in Algebra 2. And then you'll need it in Algebra and Trig. And then you'll need it in Pre-Cal if you go that far. If you choose to go that far. Not saying you couldn't, if you choose to. You will need this formula forever and for always. Unlike the last formula, this one is just going to give you one number. You're not finding a coordinate, you're finding how long it is. So I might say, here's 2 coordinates on the coordinate plane. Shazam, shazam. How long is the segment that's made by those coordinates? And that's the formula to find that. Now, Brandon asked us a question a minute ago that's extremely important right now. He says, how do you know which point is x1, y1 and which point is x2, y2? Because subtraction is not a commutative process. Order matters there. However, the reason that it still doesn't matter which point is which, as long as you're consistent, that's how it's drawn up there. If you notice, there is an absolute value in the problem. But what happens when you square a number? What's negative 3 squared? What makes it positive? Exactly. When you square a number, it doesn't matter if it was negative or positive, which is why the order doesn't matter. Because 4 minus 1 is 3, 1 minus 4 is negative 3, but if you square 3 or negative 3, you're still going to get 9. So it doesn't matter which point is which as long as you're consistent. Let's look at a problem. Yes, sir. I see what you're saying. If it was just this, then yes. But this addition changes that. Because here's a good example. What is the square root of 9? You're doubling it. Square root of 9, 3. What's the square root of 4? 2, right? So if I had the square root of 9 and the square root of 4, that would make sense to just be 3 plus 2, right? Which would be 5. However, what's 9 plus 4? What's the square root of 13? Is that 5? No. Well, by adding under here, these two are kind of married, so you can't just break them up and cancel the square roots. Good observation. If they were by themselves, you absolutely could. But this addition changes everything. Okay. To our problem. What is the length of RS given those endpoints? I'll work this one for you, and then I'll give you one to try on your own. And if we're comfortable there, we'll be done. Sure, you can. I'm going to be giving you another one. So I'm not going to wait. But yeah, absolutely if you want to. Alright, the formula. Actually, I have it under here. There's no point in me writing it. I'll just undo it slowly. We're going to use the distance formula. The first thing they did was they graphed it. There's the graph of it. There's 2, 3, and 4, negative 1. You don't have to graph it, but sometimes it helps people to visualize. So we're finding the length. Alright, there's the distance formula. x2, x1, y2, y1. Then they plugged in their coordinates. They plugged in the x's. Oh, where is it? 4 and 2 for the x's. Now they use this x first, so now they're going to use this y first. Negative 1 minus 3 for the y's. Four minus 2 is 2 squared. Negative 1 minus 3 is negative 4 squared. That's 4 plus 16, which is the square root of 20, which they got down to 4.47. So 4.47 would be which answer? C. Yeah. You put what in the calculator?
Oh.
Oh, really? Very nice. Very nice. Okay, if that's the way you prefer to do it, then by all means go for it. Questions about anything you see on the board? Because you're about to try your own. Here's the important thing. Common mistake. It's very common for people to put the whole first coordinate, 2 minus 3, and then 4 minus negative 1. You have to remember your x's go together and your y's go together. Very common. Okay? Please make sure you differentiate those. Alright. Last one. Try this one, and I'll be confident we'll be finished. As you work, I will also slowly work, in case you want to check your work with mine. The problem is on the board. Raise your hand if you have a question about where I got any of those numbers, why we did something the way we did, anything like that. Okay. I know at different points in the year some of you will be asking for extra credit. Well, that's not going to be readily available. However, periodically I will give problems for bonus. If you do that problem, it will count as extra credit. Now, you should know, I use a total point system. So you getting an extra point or two on a homework is just like you getting it on a test. It's going to go toward the same total. So you could really be giving yourself bonus for a test by doing those, but it's not required. The required part is written above.